Here we're asked to find the derivative in 3 examples involving natural log. So let's check out the first one. Part A says y equals natural log of 2x to the 8th. There are actually 2 different ways to approach this. The first way is to break it up like so. Let's use the properties of logarithms to break this up as natural log 2 plus 8 natural log x. That's just the properties of logarithms right there. And then we can quickly jump to the derivative. Y prime equals, okay, well the derivative of a constant is 0, so plus 8, and then the derivative of natural log is 1 over x, so that just becomes 8 over x. There we go. Alternatively, we could use the chain rule on this just to show 2 different ways. So recall that the derivative of natural log of u is 1 over u times u prime. So using the chain rule, we get y prime equals, okay, natural log of 2x to the 8 becomes 1 over 2x to the 8. This is the derivative now, times the derivative of the inside, which is 16x to the 7th. We can simplify that down, and indeed we get 8 over x, same thing we got before. So 2 completely different approaches, and thankfully they yield the same result, so math is not broken. Let's move on to B. We have y equals natural log of the absolute value of sine x. Well, this derivative would be the same if this was an absolute value of u, so I'll just add that in there. So let's use the chain rule on part B here. So we get y prime equals natural log of sine x becomes 1 over sine x times the derivative of sine x, which is cosine x. All of this simplifies to cotan of x. Moving on to part C. For part C, we have y equals natural log x over the quantity natural log x plus 1. Well, that's a quotient, so we're going to need the quotient rule. Low d high minus high d low over the square, and away we go, so to speak. So here we go. Y prime then is low d high, so natural log x plus 1, low, times the derivative of the high, d high, natural log x, when you take the derivative of that, you get 1 over x, minus high, natural log x, times the derivative of low, d low. Derivative of natural log x plus 1 is 1 over x again, all over the square, and away we go, natural log x plus 1 quantity squared. Okay, so we distribute this 1 over x through to both those terms. That's going to give us a little bit of cancellation here. Y prime equals natural log x over x plus 1 over x minus natural log x over x. And look at that cancellation. Oops, first, before we do that, all over the same denominator, natural log x plus 1 squared. There's our cancellation, giving us a final answer. We can just combine those denominators there. Y prime is then 1 over the quantity x, natural log x plus 1 squared. And sometimes people say, well, why can you do the denominators like that? It seems like you skip steps. Well, no, if you have a over b all over a c like that, you can just think of this fraction as bumping down one level. So this becomes a over bc. The denominators just combine. Why? Well, you can think of this as c over 1 multiplied by the reciprocal, etc. So there you have it, 3 derivatives using natural log.